Philip at this side.
Okay, I'm recording it.
Thank you.
Right, so that's transformer A, that's transformer B. And this is our transformer that we can use for tap change or a phase shift. Now, first of all, we are going to look at a phase shift. Okay, so now we have V1 on that side, and then the two transformers, and a load on V2, which is 1 angle 0. There we have a load ZL is equal to 0.8 plus J0.6 per unit. Now the voltage on the secondary side is 1 angle 0. And we have a tap change, a phase shift of 4%, 4 degrees on transformer B. So IB dash is IB at an angle of 4 degrees. And now let's start with our equations. We know that SA is V2 times the conjugate of IA, and SB is the conjugate of V2 times IB. So I2, which is I load, is V2 over Z load. That gives us 1 angle minus 36.87. Now IA, if we look at it, we have V1 this side and V2 on that side. So the current flowing through IA is going to be V1 minus V2 over the reactance of the transformer. Now I said it's 1.1 per unit. So therefore it will be V1 minus 1 angle 0, which is V2, divided by 0.1 angle 90. So then it becomes V1 minus 1 angle 0 times 10 angle minus 90. Are you with me so far?
Yes.
Right.
Yes.
Huh? Right, IB. Look at where is it? The current is flowing from there to there. So IB is going to be V1 minus V2 dash divided by the reactance. Now remember, there's a phase shift across the transformer. It was 4 degrees on that side, and it becomes minus 4 degrees on that side, because we've got a 180-degree phase shift. So therefore, it will be V1 minus 1 angle minus 4 times 10 angle minus 90. Have you got that? Now, if we look at point M and we apply Kirchhoff's current laws, then IA plus IB dash is equal to I load. So we said that IA is V1 minus 1 angle 0 times 10 angle minus 90, which is that one. And now IB dash will be IB times 1 angle 4. Because we're now moving again across the transformer, so we have to apply that again. And that then is equal to 1 angle minus 36. So if we now write our equations down and we simplify, we get 10 angle minus 90 V1 minus 10 angle minus 90 times 1 plus V1 times 10 angle minus 90 times 1 angle 4. That means we have 10 V1 angle minus 86. And then 1 angle minus 4 times 1 angle plus 4 becomes just 1. times 10 angle minus 90. And therefore we have 10 angle minus 90 V1 plus 10 angle minus 86 V1 is equal. And now we take those two numbers across. It's 1 angle 36 plus 20 angle minus 90. So if we add them, we get 19,998 is equal to, okay, angle 8 minus 88 V1. That gives us 20.616 at an angle of minus 87.8. And if we divide, we get V1 is 1,0314 angle 0.2 degree per unit. Now we can calculate the loading of A and B. Oh, come on. So IA, we can calculate it from that one, V1, so that'll be 1,0314 angle 0.2 minus 1 angle 0 times 10 angle minus 90. That gives us 0.3162 angle minus 83.5. And IB dash, sorry, will be I load minus IA. And that gives us a value of 0.816 angle minus 20,52. So SA will be 1 times the conjugate of the current, which gives us 0.3162 angle 83.5. SB is 1.816 angle 20.52, and that gives us 0.816 at an angle of 20 degrees. Now, let's say those transformers were without any phase shift or tap changing. Then we would have had a condition like that. Because the impedances were the same, each one would take half of the current. If that was I load, which was 1 angle minus 36,87. Now each one is going to take 0.5 at an angle of 36,87. So now we can calculate the percentage change in P and Q. Now for transformer A, if we take that 0.5 times the cosine of 36.87, which is 0.8, then we get 0.4. And that value, 0.316, if you take that to rectangular form, you will get a P and a Q value, which was this, 0.04. And a percentage change, we always take it as the original one, so that's 90% change. In B, it was 0.4 and 0.76 divided by 0.4, that gives us minus 90%. So this one took over 90% of the load. And reactive power, Q, only 6.67%, and that one changed 4.67. Now, as you will see later on, we have got a phase shift and a tap change. Now, a phase shift changes P, and a tap change changes Q mostly. So now we saw with this example that P changed 90%. Now, let's take the same example and let's say we have a step-up transformer.
We can't see the drawing.
All right, I'll show you just now. It's the same as the previous one, except let me just try and make it so that I can write as well. Okay. Let's take the same per unit load. Z load is 0.8 plus J6,6. Each one of these is J0,1. That is V1. This is V2 referred. That will be IB. That will be IA. IB dash is on that side. And this voltage here is V2, which is 1 ∠0. Now let's say we take this to be a step up. So it's 1,03. Now, if we have a step up transformer, what's going to happen to the current on this side?
Current on the low voltage side,
Yes,
will it decrease? Because the current in the high voltage side should be less, I think.
yeah. Okay, so what does that mean? V2 dash is going to be what is the voltage going to be, lower or higher for a step up transformer? Let's say this is 1 ∠0. What will it be on this side? 1?
1 ∠180.
No. Remember, it's a tap change now. So that'll be 1 divide, no? Because it must be lower. Because it's a step-up transformer. You agree? Remember? Let's say we have the transformer there.
So could you kindly shift your page so that we can see what you're writing?
There you are.
Thank you.
So if this is a 3% tap change, and this is 1 ∠0, what's the voltage going to be on that side? Because it will be lower, no? By the tap change.
Okay.
Okay. Hi guys, this is stuff that you've done in machines too. You probably forgot. Or you never did machines too. Okay. So now the procedure is the same. I load going to be V2 over Z load. That'll be 1 ∠0 divide by 0.8 plus j 0.6. That is 1 angle minus 36,87. IA going to remain the same because it's V1 minus V2 divided by JXA. That gives us 10 angle minus 90 times V1 minus 1 angle 0. Now, because that's the difference between those 2 points. There's V1 and there's V2. Now, IB will be V1 minus 1 angle 0 divided by 1,03 divided by JXB. So that will be 10 minus 90 and V1 minus 1. So IB dash. Do you agree that it's going to be lower? So that will be IB divided by our tap change. So that means it will be 10 angle minus 90 divided by 1,03 times V1 minus 1 angle 0 divided by 1,03. Now again, we can apply the Kirchhoff's rule to M. Then IA plus IB dash will be equal to I load. So therefore, we have 10 minus 90, V1 minus 1 angle 0, plus, now we have 10 angle minus 30, minus 90, divided by 1,03 times V1 minus 1. That will give me, what do we have? 5 minutes left. Okay. I'm gonna reconnect again. Then I'll send you the new. Is 1 angle minus 36,87. So we have 10 minus 90 V1 minus 10 angle minus 90. Now we have, where's my calculator now? 10 1.03 divide, that gives us 9,709 angle minus 90 V1, and now 9,709 and enter 1.03 divide times, now that fraction becomes 9,426 angle minus 90 is 1. Can you see that? Oh, here's another guy that wants to enter. All right. So now we can add the V1s, 10 angle minus 90 V1 plus 9,709. Yeah. Yeah. 709 minus 90 V1 is then equal to 1 minus 36,87 plus 10 minus 90 plus 9,426 minus 90. All right, so that gives us 19,709 angle minus 90 V1. And just add this stuff. One. That gives us 20,04 minus 87,71. So V1 will then be that divided by 19.709 angle 90. Then we get an angle of 1,016. Make it 768. Angle 2,288. 2,3. So now we can calculate our current again. Okay, we've got less than a minute. Right, so IA is going to be 10 minus 90 times 1,017, 2,3 minus 1 angle 0. Yeah.